What's going on, guys? So in this video, I'm going to walk you through setting up a development workflow for React apps within Docker containers. I'm going to show you how you can tweak this workflow for both your development environment as well as your production environment. So let's initialize our dummy React app. So we're just going to do an npx create React app. And we're going to initialize this in our current directory. Now that that's complete, let's start our development server by doing an npm start. And doing that should then go ahead and start your React app. So we're not going to touch this app. It's just merely there for demonstration purposes. In the next section, we're going to work on setting up our first Docker container and then working our way into making sure that we can get this app running within that Docker container. All right, guys. So for this video, I'm going to assume that you already have Docker installed on your machine. If you don't, go ahead and look up the instructions. The Docker documentation is fantastic. So it's fairly easy to set up Docker on any operating system. But once you have Docker set up, go ahead and navigate to hub.docker.com. So this is a repository of public Docker images, so pre-built images that we can use for any of our projects. And what we're going to do is we're going to search for Node. And so, React runs on top of Node. So I think it makes sense to look for a pre-built Node image and go ahead and select the first result. So this is the official Node image. And this is ultimately what we are going to use for our application. It's just a lightweight image that already has Node installed for us, so we don't have to worry about installing it ourselves. Now, this image isn't really going to contain anything else other than Node. It's a bare image, just has Node installed, which isn't obviously going to work for us because, the idea behind containers is it's going to contain every single thing that we need for our application to run. And that includes our source code, that includes all of our dependencies and anything else our application may need. This image doesn't have that. So what we need to do is we need to take this image and customize it. So we need to take this image, we want to copy our source code into this image, and we want to install all of our dependencies into this image so that this image can deploy pre-built containers that have everything that we need to actually run our application. And to customize an image, we have to create a Dockerfile. So let's go to our project folder, and I'm going to create a new file, and I'll call it Dockerfile with a capital D. And so this file is going to contain all of the steps that we need to customize an image. And the first command that we need to run is called from. So we want to capitalize all the letters, and we say from, and then we specify a known image. So anytime you're customizing an image, we have to give it an image that we want to customize. So we're going to customize that Node image. And I know it's called Node because of the documentation. So if you look at the documentation down here, you could specify Node, and then you can also specify a specific version. So right now, if I just do Node, I forget what the default version is. If you read the documentation, it's going to tell you it's probably like version 14. I think there's a latest tag that one of these is going to have. So maybe it's this one. So this could be the latest version. But you can also specify a version. Right now, I'm just going to leave it as a default. But if you wanted to specify version 15, you can do that as well. The next command is called workdir. And so what this does is it's going to set the working directory of our container. So I'm going to set this to the /app directory because I know this directory exists in the container. And what this ultimately does is that anytime we run any commands, anytime we copy any files, it's going to run those commands and copy those files into this directory. So we know that anything related to our app is going to be stored in that directory. So technically we don't need this command for anything, but it makes working with our container a little bit easier. Now, the next thing that I want to do is I want to take our package.json file and copy it into the image, right? And then that way, once we copy the package.json file, we can do an npm install to install all of our dependencies because the package.json has the list of all the dependencies that we need for our project. And so we can use the copy command, and we can say copy, and then the path to the file that we want to copy or the directory. We can copy an entire directory, but we just want to copy our package.json. And since it's in the same directory as the Dockerfile, I could just type in the name of the file, which is package.json. But if it was in another directory, you could always do like /source/whatever, right? So package.json, and then we have to specify the directory that we want to copy this file to in our container. And so what we can do is I can type in dot, right? So that means the current directory in the container. And what this is going to do is this is going to copy it into the /app directory because we set the working directory to be /app. So anytime we copy files and we just put the dot, it's going to put it in the /app. We could also just hard code the full path and just type in /app. It'll do the same thing. But once again, since we have that workdir command, we can just specify the dot. After we have our package.json copied over, the next thing that we want to do is run an npm install. So to run a command in our container, we need to do a run npm install. So that's going to install all of our dependencies. Now the final thing I want to do, well, it's not the final thing, but there's a couple more steps. So the next thing that I want to do is now copy the rest of all of our code or the rest of all of our files into our container. So we can do a copy and then dot. So everything in the current directory. And I want to copy it to, once again, the /app directory. So I just do dot again. And now I know you might be a little bit confused at what we just did right here, because you'll notice that we copy the package.json file, and then we do an npm install, and then we copy all of our files over, right? And when we do a copy with the dot, that's going to copy all of our files, including our package.json. So you might be wondering, well, why did we copy the package.json by itself? And the reason for this is a little bit of an optimization. Technically, you didn't need to do it, but Docker likes to optimize things and make things quicker for future builds. So let me explain how Docker works. When we're creating an image like we are with this Dockerfile, each command that we have, so we've got 5 commands right here, is a layer of our image. So Docker builds these images based on these layers. So we have 5 different layers. And what Docker does is, when we build our image for the first time, it's going to cache the result of each layer. So layer 1 says, hey, we need to pull the node image from Docker Hub, and then it caches that result. We then set our working directory to /app, and then it caches our result. We then copy our package.json, it copies the result of that. We do an npm install, it copies the result of that, and then we copy the rest of our files, and it caches the result of that. And I want you to think about exactly how our development environment's going to, our development workflow is going to work. When we're actually working on our code, we're going to be in our source directory, we're going to be changing our code. And we rarely ever touch our package.json file, right? There's going to be times when you're developing where you do install new packages, but for the most part, you're not installing packages regularly, right? Only when you specifically need it, which is occasionally. And the way that, and I mentioned how we have caching. So the reason why we split this up is that since package.json doesn't change very often, it's going to cache this result. And then since package.json doesn't change, running an npm install doesn't change anything. So it's going to cache that result. However, since we are changing source code, right, it means that it will have to rerun copy. Every time we change our code, it's going to have to rerun the copy to copy the rest of our files. However, if we didn't have these 2 lines before then, and we put, let's say we just deleted this and then moved the npm install underneath it, that would mean that every time we changed our source code, it would have no idea. When I say it, Docker would have no idea whether we changed our source code or we changed the dependencies in our package.json. So every time we ran a copy, we would have to then do a full npm install, regardless of whether or not the dependencies changed. So we would be unable to take the cache result. So by splitting this up, we can ensure that only when we change our package.json will we have to run an npm install, and that is a very time-consuming task. That's actually going to take the most amount of time when creating our Docker image, is running the npm install and installing all the dependencies. So a little bit of an optimization. Hopefully that made sense, but if it didn't, you'll see that when we actually go to build our images, it'll make a little more sense. All right, so now after we copy all of our code, the next thing we want to do is remember our app listens on port 3000, so we want to expose port 3000. And then finally, we need to do an npm start to actually start the development server. So we'll type in cmd, and we'll say node. Whoops, not node. Npm start. All right, and so this should be everything that we need. So let's save that. And then now let's stop our server that's running on our local machine, because we're no longer going to be developing on our local machine or our host machine. We're going to be developing in our Docker container. So let's stop that. And let's go ahead and build a Docker image from this Docker file. So the way to build a image from a Docker file is to do docker build and then the current directory of the Docker file. So you specify the path to the directory of your Docker file. So we're already in React Docker YT, which is the project directory. So we can just do a dot, which means our current directory. and it's going to find a file called Dockerfile. So let's do that. And I want you to pay attention to the output. This output's actually very important. If you notice, it says step 1/5. Like I said, Docker treats each one of these as a separate layer or as a separate step. And you'll see that it caches the result of each one of these things. So we pull the node image, we copy workdir to /app. You'll see that this says it's cached probably because I ran this before for testing purposes. But it's going to run through the other ones. And you'll see that the second time that we run this, if we change nothing, it'll run so much faster because all the results are cached from each one of those 5 steps. But notice how the npm install is what's ultimately taking the longest amount of time. Right, you can see how long each step actually takes. So that was it. Right, it's already over 33 seconds, whereas the other 2 steps took, 11 seconds? All right, so it's complete. To verify that our Docker image got created, we can do a Docker image ls. You can see I've got a ton of images. I know that the last one that got created 11 seconds ago is the one I created, and you'll notice that there's no name, and that's a little bit of a problem. So let's go ahead and delete that image and then create a new one, but let's give it a name this time. So I'm going to copy the image ID. I'm going to do a Docker image rm and then paste that ID. All right, so it deleted that image. And now what I'm going to do is I'm going to hit the up arrow till I get to that, till I get to the Docker build command. And this time I'm going to pass in a -t flag. So this is going to give it a name or a tag in this case. And I'm going to call this, we'll call this React image, although it looks like I already have an image called React image. So let me delete that one first. Actually, I'm just going to overwrite it. It's fine. So we'll do React image. Right, and notice how the second time we ran, it ran much, much faster. And that's because you can see that steps 2, 3, 4, and 5, the results were all cached. So running it again was much, much quicker. However, if I changed anything from any of these files, you'll see that it'll have to rerun them because those results aren't cached. And keep in mind, let's say we change what's in our package.json. If we can no longer use the cached entry because this line changed, Docker has no idea if these lines change as well. So anytime a line changes, we're going to have to rerun all of the steps after it as well because it has no idea if those changed or not. So once again, that's ultimately why we moved that package.json line by itself to kind of optimize it a little bit more for us. So if we do a Docker image ls, we got our React image. And so from that React image, let's go ahead and create our first container. And so to create our first container, I'm going to do a Docker run. And then we want to specify the the image name. So we have the React-image. We'll do React-image. Now there's a couple other flags I want to pass in. So I'm going to do -d. That's because, whenever you do the Docker run command, by default, it's going to attach to the container, and I just want it to run in the background. And then I also want to give it a name. So I'm going to give it a -- name. I'm going to call this React-app. And let's hit enter. All right, and let's do a Docker PS. This is going to show all your running containers. You'll see that I have a couple of other containers. I've got this Docker React app. Don't worry about that. Same with this Docker dind. The one we want to focus on is the one right here called React-app. Okay, and so now that it's running, let's go ahead and go to localhost 3000, and let's hit refresh, and let's see what happens. All right, so it's spinning, and that usually means something's broken. And there we go. So this is expected. So in the next section, I'm going to explain exactly why we can't connect to our React application now that it's running within the Docker container. Okay, guys, so let's try to figure out exactly what went wrong. So if we go back to our source code, you'll see that in our Dockerfile, we did expose 3000, port 3000. So why exactly can we not reach it? Well, the reason is that this means nothing. This command does nothing. It's more for documentation purposes. But at the end of the day, there's no way to actually reach the container at the moment. And so that's why going to localhost 3000 means absolutely nothing. The container is just kind of sitting by itself in its own isolated network. And that's kind of an important thing to understand with Docker containers. And that is that, when you create a Docker container, by default, even though the container itself can access the internet, and we know it can because it ran an npm install, and the only way for that to work is if it had internet access. Even though it can reach the internet, the outside world can't talk to containers by default. So when I mean the outside world, I don't mean just the internet. I'm talking other devices on your home network. I'm talking even my host Windows machine, right? My Windows machine is considered an outside device from Docker's perspective. So that container, even though it can talk to us, it can talk to the internet, we can't talk to it. We can't initiate the connection. And that's an important thing to understand. So what we have to do is we actually have to poke a hole on our local machine and basically say that, hey, traffic that comes in on a specific port to my local machine, which once again is this Windows with this Windows machine right here, I want to forward that traffic to this Docker container. So how do we actually do that? Well, first of all, let's kill our container because that thing's not going to do anything at this point. So we'll do docker rm, then we can use the container name react-app. Now, normally if you want to kill a container, you have to stop it first, but that's a waste of time. So I usually like to pass in the -f flag. That'll allow you to kill a container that's actively running. So we'll do that. And then once that's done, we'll just do a docker ps. Let's just make sure it got removed, and it did, so perfect. And now I'm going to hit the up arrow till I get to my docker run command, and I'm going to pass in another flag. Doesn't matter where I pass it in, but I'm going to pass in the -p flag. And I'm going to do 3000:3000. So let me explain what this is. So there's two numbers separated by a colon. The first, let's actually take a look at the number to the right of the colon. So this number dictates what port we're going to send traffic to our container. So our container, our application, is listening on port 3000. So we want to forward all traffic to port 3000. So that's why it's set to port 3000 on the right side. The number on the left side is the port that we need to send traffic to on our local machine. So this is saying that any traffic sent to my Windows machine on port 3000 will get forwarded to port 3000 on the Docker container. Now, keep in mind, these numbers don't need to match, even though I made it match in this case just because it's simpler. Why not? But if I set this to be 4000, that's 400. 4000. Oh, I have insert enabled. That's why. Okay, hold on. There we go. 4000. So what this is going to do is it's going to say anybody in the outside world, any other devices on my network, anyone on the internet, anybody that sends traffic to port 4000 on my local machine is then going to forward it to port 3000 in my Docker container. And so that's ultimately going to fix everything. I'm going to change this back to 3000. I've set up a couple of slides. Actually, it's just one slide in PowerPoint to explain this a little better. Hopefully, I just want to make sure that we're all on the same page when it comes to how this kind of port forwarding actually works with Docker containers. Okay, so we have our host machine in the blue here. So this represents my Windows PC. And then somewhere on my machine, we have a React container running. And so the idea is that we want to send traffic that comes to my host machine, my Windows machine on port 3000, and forward that to port 3000 on the React container. So anytime anyone in my local network or anybody outside of my host machine that sends traffic to me on port 3000, my Windows machine is just going to naturally forward it to the React container on that same exact port. And the same thing applies when I go to my web browser and I type in localhost :3000. So that's basically initiating a connection from the outside world as well. So I'm sending it to localhost 3000, and my machine once again is going to forward that to port 3000. So hopefully that made sense. Just keep in mind those two numbers don't need to match, but I just think it makes things a little bit simpler. So I'm going to hit enter, and let's see if this fixed our issue. Yep, and look at that. So now we have successfully connected to our Docker container on port 3000. So now that we got our React application to work inside our Docker container, I actually want to connect into the file system of our container and take a look at a few things. And so if you've never actually connected into the file system of your Docker container, it's easy to do. All you have to do is type in docker exec, and then you want to pass in the -it flag for interactive mode. Then you pass in the name of the container. So we gave it a name of React App. So I can just copy that. And then Now what we want is we want to override the default command of the container. So the default command is an npm start. Our application's already running. We don't want to do that. Instead, we want to run the command bash so we can take a look at the bash terminal of our Docker container. And so now we are actually in our Docker container. It's going to automatically drop us into the /app directory just because that's the working directory. And here, if I do an ls, this is going to print out all the files in the /app directory of our container. And you can take a look at all the files. And so because we ultimately did a copy, you'll see that we copied over our source folder, our public folder, we got our package.json, we got our node modules, we got our README, and then, interesting, we have our Dockerfile here as well. Now that makes sense because we are copying everything. However, do we actually want our Dockerfile in our container? We only need our Dockerfile to build the image, but it doesn't need to be in the image. And so that's a little bit of an issue. I mean, it's not going to break anything, but I think you're starting to see where I'm going with this, right? There's going to be certain files that we don't want copied over into our container. On top of that, you'll see that we have our node modules folder on our local directory. When we do a copy, we are copying our node modules folder over. And there's absolutely zero reason to do that because we're running an npm install. And this node modules folder could be massive. And that's going to take a lot of unnecessary time copying this folder over when we already have all of the dependencies installed from npm install. So clearly we can see that there needs to be a way to ensure that we don't copy certain files over. Not just the Docker file, not just our node modules folder, right? We've got Git folders. We've got our git ignore. We might have a folder that stores all of our secrets. We obviously don't want those copied over into our container. So how do we actually prevent that from happening? Well, we can create a file called a dockerignore file. Very similar to a git ignore file. In fact, same exact concept. So let's create that. We'll call it .dockerignore. All right, and so let's specify the files we don't want copied over. So we don't want the node_modules folder being copied over because we're running an npm install. We don't want our Docker file copied over. We don't want our Git folder copied over. We don't want our git ignore copied over. And now that we have a dockerignore file, let's make sure we don't copy that over as well. And we might have a env file that stores all of our environment variables. We probably don't want that copied over as well. And we're going to add that in the future or a couple of minutes down the road. So let's save this. I'm going to exit out of this Docker container. And let's go ahead and kill the current running container. So docker rm react -app -f. All right, so we have our new dockerignore file. And so now if we do a docker image ls, we don't want to create a new container because it's still going to use the old image, which automatically has all of these files baked in, and it didn't factor in the dockerignore file, which we just created. So we're going to have to rebuild the image. So I'm just going to keep hitting the up arrow until I get to that docker build command. And I'm just going to rerun that same exact command. All right, and so now we've got our new image. Let's run that container from that image. So we'll do, actually I could just keep hitting the up arrow until I get to that same command. Let's see, where is it? Here we go. So we're going to run this command right here. And once that's run, let's go into bash by doing that docker exec command. And let's just verify those files aren't there. And so when we do an ls, we can see that the Docker file and the dockerignore file are not there. Now we do see a node modules folder, but once again, that's not actually from us copying it over. That's actually from running an npm install. No way to prove that, obviously, but hopefully you guys can just take my word for it. All right, so let's connect back to our application. And let me just hit refresh just to make sure everything's still working, and it is. And I want to go to our code, and let's just say we are actively developing our project, and we make some changes to our code. So let's go to our app.js file, and I'm just going to add another p tag. And I'm just going to say, hello there. We'll hit save. And now let's go back to our app. It looks like we don't see it. Normally React apps, when you save it, node mod's going to automatically restart it and show you the changes. Let's try refreshing it, see if that changes. And it looks like nothing's changed even when I do a refresh. So something is clearly broken. And Once again, let's go ahead and investigate why. So I'm still connected into my Docker container. If you haven't, if you already exited out, just run that docker exec command, right? And do an ls, you'll see all the files. Let's go into our source folder. And let's actually take a look at the app.js. Let's see if those changes actually got propagated into our Docker container. So if you want to print out the contents of a file on a Linux operating system, you just do cat and then app.js. Okay, so that's going to print out the contents of that file. And if we take a look, you can see that we do not have the extra p tag that was created or that we just created a few seconds ago. So what exactly happened? Why is the code not updating in our Docker container? And that's a really easy answer. Think about the steps that we performed, right? The first thing we did was we ran a Docker, let me exit out here. We ran a Docker build, which runs these commands. So it copied our code, right? And the code it copied over was, we ran this before we made the code changes. So before that extra p tag got put into place, it then created an image, right? And that image that we created is right here. However, that image does not have the changes we just made because it was made, over 4 minutes ago. And we made those changes, 30 seconds ago. So we have a stale image, all right? And then we ran a Docker run, which then runs that code. But nowhere are we telling the container or the image to update those changes that we make on our local file system. Because at this point, we just changed it on our local file system, but nothing's been updated on our Docker container. So this is a little bit of a problem from a development perspective. How do we get it so that the code actually syncs, so that our code actually shows the changes that we make? Well, the first thing that we can do is, let's go ahead and kill our container as usual. Let's make sure everything's saved, with our changes. What we can do is we can just build a brand new image. So we can do docker build -t. What did I call this? React-image, and then specify the context, which is where our Dockerfile is ultimately. Run that. So now, if we do a docker image ls, now our image has the updated code. So if we do a docker, let's just hit the up arrow till we find that docker run command. Let's run that. Now, if I hit reload, we can see the hello there. All right, so that's how we updated the code, because now our image is no longer a stale image. However, here's the problem with doing that. If I change my code again and say, I don't want this p tag anymore, hit save, right? Once again, it's not going to update automatically. I'm going to have to go through that whole process of rebuilding the image and rerunning the container, which obviously is not a scalable or maintainable solution, because for any code change, if you want to just quickly test it out, you'd have to kill a container, you'd have to rebuild the image and then deploy a new container, and that would just slow your development workflow down to the point where you can't get anything done. So there has to be an easier solution. And there is. What we're going to do is we're going to make use of something called volumes in Docker containers. So Docker containers have a concept of volumes, which allow you to have persistent data. Because right now, if you have a container with any kind of data in the container, if you kill the container, any data it has is lost automatically. And volumes just allow you to maintain that data even if your containers die. But the nice part about it is there's different types of containers, and there's a specific type of, there's a different types of volumes. And we're going to use a very specific type of volume called a bind mount. And bind mounts are really cool because they're going to solve our main problem here. And bind mounts, what they do is they allow you to take a folder, a directory on your host machine, right? That's my Windows machine. It allows you to take a folder on your host machine and sync it to a folder in your Docker container, right? And that's exactly what we want. We want to sync our project directory with the /app directory in our Docker container. So let's take a look at those bind mounts and how to actually configure them. So I'm going to kill my container. And I'm going to hit the up arrow till I got to my docker run command. And I'm going to pass in a simple little flag called -v. This stands for volumes. So you're allowed to specify as many volumes, but we just want one volume. And the way this command is going to work is we specify the directory on our local machine. So I'll just call this dir. This is kind of like pseudocode, dir local directory. And then you do : and then you do container directory. So that's the way you specify this command. You specify the path to the local directory that you want to sync, and then you specify to the directory in the container that you want to sync it to. So let's type this out now. So here, this is where it's a little bit of a problem. We have to, on this, when we do this command, unfortunately, we can't do current directory with the dot. Instead, we have to grab the full path in our operating system to this directory. So I'm just going to do a right click and just do copy path. And I'm going to paste it in here. And so we get this massive line that starts from my C drive. And then it goes all the way to app.js, but we don't need the app.js. We just need to make sure we get, actually, we don't even want to go into source. We want to just do my main project directory, which is react-docker-yt. Actually, we do want to sync the source directory because ultimately we don't care about syncing all of these other files. We just want to sync our source code. So we're going to sync our source directory. We do colon, and then where do we want to sync it to? It's going to be /app/source. And so this is going to ultimately sync those two folders up so that anytime we make changes in our code, it's going to match in our Docker container. Although what I don't like is this massive line right here. It's just so big and disgusting. And also, if you're writing this out and you happen to have a directory on your file system with spaces in it, you're going to have to make sure you wrap it in quotes, or then you're going to run into some errors. But I'm going to show you a shorthanded syntax so that you don't actually have to type out that entire line. And it's going to vary from operating system to operating system. But if you're on Windows and you're using PowerShell, which in this case I'm not, I'm actually using the standard command line. But if you're using the PowerShell, what you can do is you can type in $ curly braces, and then within there you can type in pwd. So that's going to grab the current working directory, which is exactly what we want. And then you can do, /src. If you are on the Windows command line, the main terminal, you can do, instead of curly braces, you can do %cd%. And that's going to grab the current working directory, and then we want to go into the source folder from there. So it's just like a variable that you can save. And then finally, if you're on Linux, you can do $ and then parentheses, and then pwd. And remember, on Linux, it's always /slashes. So either one works if you want to do the full path, but you can do that. Also, this works for Mac as well. So Mac is basically just running Linux. So if you're running Mac, go ahead and do that. I'm going to change this back to what I need to for my Windows operating system, which is going to be %cd%, and then on Windows it's /. So this is going to sync those files together. Let's run that now. You're going to get a warning. So if you're using WSL2 on Windows, you're going to get a warning. It's recommended to mount the Linux file system onto your machine and then put your code on that Linux file system. I didn't bother doing that, so it's just letting me know that it may not be optimized or it may lead to issues. So just keep that in mind. All right, so we got that. Our app is running. Let's go back to the web browser. Hit refresh. It's working. Let's go back to the code and let's make some changes. I'm going to put another p tag. Say hello there again. Let's save. And let's hit refresh. And once again, it didn't work. Now, for some of you, it may have worked. This is actually a Windows issue. And so to get this to work, we actually have to pass in an environment variable. But like I said, this is strictly a Windows issue. So I'm going to kill my container. And I'm just going to keep hitting the up arrow. And I'm going to pass in one more flag. So if you want to pass an environment variable into your container, you just do the -e flag. And what we want to do is this chokedar. I don't even know what that means, but this was just from Googling. So chokedar, and then you want to set that equal to, actually, sorry, it's chokedar _ use polling. Set that equal to true. And that should fix our issue, hopefully. All right, so let's refresh that. Let's just make sure it's working. Okay, so We got the new hello there, but that's because it was already there. Let's make the change now. So if we change this to be hello, Sanjeev, hit save, pray it works, and look at that. We can now see that the code is in fact updating on our local container, and React is automatically restarting the application so that we can see those changes. And so that's basically how we can use bind mounts to sync our code from our local directory to our Docker containers app directory. Now, with bind mounts, this creates one minor issue, and that is that the syncing between our local file system and the container file system is a two-way street. So if we make changes to our local, to our code in our project directory on our local machine, it's going to sync it to our container, which is exactly what we want. However, our container can make changes to our code or create new files or delete files, and that's going to get synced to our project directory. And I think you're probably thinking, well, why would the container ever make changes? Well, it shouldn't, but why even give it the option, right? So if we actually log into our container by running the docker exec command, I'm going to navigate into the /app/source directory where we copied our source code, and I'm going to run this command called touch. So on a Linux file system, this creates an empty file. I'm going to call this hello. Now I want you to notice something. When I create that file, look at that. It syncs to our folder on our local machine. And so there's really no reason why we ever want our container to be making changes to our source code or touching any of our project files. We just want it to receive the changes, but we don't want it to make any changes. So the way we can do that is by making that bind mount read only. So let me show you how to do that. I'm going to exit out of that. I'm going to kill my Docker container. We do docker rm react-app and then -f. And I'm going to delete this file because we don't need it. And I'm going to hit the up arrow till I get to my docker run command. And I'm going to go up to my volume, my bind mount. And at the end, I'm going to do a colon. I'm going to do RO. So what this is saying is that this bind mount is going to be read only. So our container can read it, but it cannot make any changes to it. It cannot change any of our code. It cannot change any files. It cannot delete or create any files. So let's run that. And now I'm going to do a docker exec again to log into the file system, go into our source directory, and I'm going to do that same touch command. And look at that. When we run that, it says this is only a read-only file system. So a little bit of a protection mechanism, a little bit of security mechanism, just to ensure that your container doesn't mess with any of your source code. However, if there is a specific need for the container or your application to actually make changes to the files within your Docker container, then you obviously wouldn't want to do that. Okay, so the next thing I want to introduce is working with environment variables when it comes to our Docker container. And I already kind of showed you guys a little bit when it comes to environment variables. We saw that to get around the issues with Windows machines when it comes to updating the code, we had to pass this environment variable right here, right? And the syntax is you pass in the -e flag, and then you just say the name of the environment variable and then what value you want to set it to. So this value is true for this environment variable. So what I want to do is I actually want to put in an environment variable into our source code so that we can actually test and verify if the environment variables that we set are actually working. So where it says hello here, instead of hard coding my name, what I'm going to do is I'm going to change this to a template string. I'm going to say, actually, first of all, this has to be in curly braces so that React knows this is JavaScript coming. We say hello, and then we'll do string interpolation, and then we'll say, to grab the environment variable, we're going to do process.env, and let's just pass in a environment variable called React_app_name. So if we pass this environment variable in, it's going to be passed into this string right here. And remember, when it comes to React applications, you have to prepend the name of all of your environment variables with React_app. Okay, let's save that. And let's go to our Dockerfile. And let's add a default environment, a default value for that environment variable. So we can do env. And we can say React_app_name. And we'll just set that equal to my name. All right, and I'm going to kill my container. Now, since I made changes to the Dockerfile, let's go ahead and actually rebuild our image. So we'll do docker build-t react-image and then dot for the current directory. And then now let's run our container with the same command that we've been using. And if we check our code now, we can see that it passed in the default environment variable. All right, so that works, but let's override that. And I'm going to do that by, first of all, killing my container. We saw that, we passed the other environment variable by passing the -e flag. And so if you want to pass in more environment variables, you can just do -e again and then pass in another one. So this is called React App name. Copy that. And I'm going to set that equal to Sanjeev. All right. And now let's refresh this. And we can see that, look at that, our environment variable got passed in to our development server and updated the code respectively. So this can be a little bit annoying if you've got a lot of environment variables, which you very well may. And so if you've got like 10 environment variables, having to type those all out into the command is a little bit obnoxious and it makes your command look really ugly. So instead, what we can do is we can create an env file. Actually, I wanted to put it here. .env, and we can just paste in all of our environment variables. So I'm going to grab this one, and I'm going to grab this one. All right, and so now you can store all of your environment variables into this .env file. And now I'm going to kill my container. And I'm going to run the same command, but I'm going to remove the environment variables and I'm going to pass in that file. And so to pass in a file, we do --env -file, and then the path to the file. So it's in the current directory and it's called .env. And did I not kill the... Oh, I tried to delete the image, not the actual container. So hold on. I want to kill React App, not React-image. And then now we can rerun that command with the --env file. And let's pray and hope that this works. Yep, and look at that. So it's now loaded the environment variables from that env file. So use whichever one you prefer. I like using the file. Just because, when you got a lot of environment variables, it's just easier to store it in that file. Okay, so we finally got basically our main development Docker container up and running. And we have the command to do that. We hit the up arrow. You can see that we have to pass in a couple things. We've got the environment file, or you can pass in the environment variables one at a time. We've got our bind mount, which it looks like I forgot to put in the :ro. I'm not sure what happened there, but that's optional. We want the -d flag. Then we have the port mappings. We also have the name of the container, and then the image that we build it from. So this line's kind of long, and you'll see that as you keep working with Docker, some of your Docker run commands will start to get even longer than this. Like this is actually nothing compared to some of them. And it's also important to understand that generally when you're working with a Dockerized application, you're going to have multiple containers that you need to spin up to actually do all of your testing and to do your development. And imagine having to remember 5 or 6 of these long commands for you to have to run just to bring up your development environment. And then imagine having to kill all those containers one by one. Right? That's a very long and slow process. And I think it would be nice if there was an easy way to kind of write down all of these instructions in a file and then just run one command that pulls all the configs from those files. And guess what? There is a tool for that. It's called Docker Compose. So to work with Docker Compose, it's really easy. We just create a new file. I'm going to call it docker-compose.yaml. So this uses YAML syntax, which, doesn't really matter. You can look it up. But the main thing that I need you guys to understand is that when you're working with a YAML file, spacing matters, right? It's like writing Python, right? You need to make sure that things are tabbed in the right way. If you put too many spaces in one section, it's going to lead it to not work. Now with Docker Compose, we are going to provide the instructions for creating all of our containers, which in this case is just one React container, but it's going to have the instructions for that. So the first thing is we have to specify the version of Docker Compose that we're going to use. So I'm going to do a version, and I'm going to do :3. I'm going to put that in quotations too. So I'm going to do version 3. Now, when it comes to versioning, I recommend you look up this page right here. So just copy that URL. And this shows you all the different versions, and it shows you what features are supported in which version. So depending on what you need when it comes to creating your Docker containers, you could try to figure out what version of Docker Compose you need to run. I'm just going to do version 3. We're not really doing anything special. We don't need any of the newer features, so I'm just going to grab version 3. But if you do need one of the newer features, just grab the version that was first introduced, or just use the latest version. It doesn't really matter. So now that we have our version defined, the next thing we want to do is do services. So services in Docker Compose represent a container. So each container that you have is going to represent a different service. So for us, we have a React application. So we're going to create a service called React App, or whatever we want to call it. If you have a backend server, like a Node.js or Express server, you can create one called backend server. If you have a Postgres database running in a Docker container, you can create another service for that and call it like Postgres or database or whatever you want. So I'm going to hit enter. And this is important because the configs are going to go within the service block. So I'm going to hit tab once so that we know these lines are part of the services tab. And I'm going to give this service a name. You can give it any name you want. I'm just going to call it React App because that's ultimately what it is. And I think that makes sense. Now within our React App, I'm going to hit enter and do one tab. So make sure you go one tab over. So this is going to signify that all of these configs that are going to pass in are all the configs for our React App container or service. So the first thing that we have to do is we have to specify the image that's going to be used for this. And so since we're creating a custom image, we're going to pass in the build option. And then we have to give it that context, right? So if you remember, when you do a Docker build, you pass in the context, which is just basically the simplest way to think of it is just the path to the Dockerfile. So I'm just going to do a dot, but keep in mind, it's not exactly that exact definition, but I think it just simplifies it for now. The next thing that we need to do is pass in the port mapping. So we can do ports and hit tab. And here we could specify a list of port mapping. So you could technically have more than one. Nothing's going to stop you from doing that, but we're just using one. So we're just going to do the same thing. Right? And keep in mind, I'm literally just putting in the config options for each one of the flags that we've passed in. So I'm just going to go step by step. So we're going to do 3000, colon 3000. So what else do we need to do? Well, let's see. We need to define that bind mount. So let's do that next. And so now create one called volumes. And notice how all the configs are all lined up. Remember, spacing matters when it comes to YAML. We'll do volumes. And remember, you can have more than one. So we have to write out a list. So anytime you're working with lists in YAML, you do a dash and then whatever it is. So we'll do ./source :app/source. So remember here we had to use the little %cd% or pass in the full path. When you do Docker Compose, you can just do current directory and then /source. So that's a little bit nicer when it comes to working with Docker Compose. And then you can also do the read only if you really want to do, but who cares about that for now. And keep in mind, you can add as many volumes as you want. So if you wanted another volume, just do the dash and then whatever kind of volume you want to add. Next thing that we want to do is we want to pass in environment variables. So we'll do environment. And this is going to take in a list. So there's going to be two. So we'll do React_app_name equals Sanjeev. And then, if you're on Windows, you also want to pass in this one. All right. And there's actually an alternative way to do environment variables. Remember, we can do a file as well. So if you want to do a file, you can do env_file. And then you can pass in a list of files. So you can technically have more than one and then just the path to that file. So whichever one you want, I'm going to just comment this out just for documentation purposes so that when you guys look through the code, you can remember how to do it with the file. I'm just going to pass it in directly in this case. And I think that should be it. So let's save this. And now what we're going to do is, first of all, let's kill our other container if it's still up. So now I'm going to do a docker-compose. This is important. Do docker-compose. Don't do docker compose. It's a different command. So do docker-compose. And let's do a --help just to see what are the options. So we have a couple of different options, but if we look down, you'll see that we have a, up command. So a docker compose up is going to run all of these instructions. It's going to bring up all of your services, all your containers. So if you had 10 containers with a whole bunch of configs, it would spin all 10 of them up for you with one simple command. And that's really the power of Docker Compose. So let's do docker-compose and then do up. And let's do --help one more time, just to see the different flags that we have. One thing you do have is the -d flag for detached, because by default, just like when you run a Docker run, it's going to attach to the container. We don't normally want to attach to it, so we can pass in the -d flag. So let's do that, and let's see what happens. And let's take a note of the output. So first things first, the interesting thing about Docker Compose is it's going to create a new Docker network for you. So up until now, when we run the Docker run command, it puts the containers in the default network that gets created when you install Docker. When you do Docker Compose, it actually creates a new network for you. And it's called React Docker-YT_default. And that name actually comes from your project directory. So mine's called React-Docker-YT. And then it just does _default. And so once that's done, we can actually take a look at the network it created, but that's not really that important. After that, you can see it starts to build our image, right? And that comes from this build step right here. And so it's going through the different steps, a whole bunch of warnings. Who really cares about that? All right. And so after it finished building the image, which is right here, it then went ahead and created our container. So let's do a docker ps. And you can see it created a container called React-Docker-YT_React App _1. So that name is just our project directory project directory _ service name React-App and then _1, because I guess you can have multiple containers that are part of that service. So now let's go to our web browser and let's just check to see if it works. It looks like it's working. Let's just change our code. And so I'm just going to just add some stuff, right? Whoops. Yep, and there you go. So you could see that it actually did update. Perfect. Now, one thing I do want to point out, actually, now let's go ahead and actually remove our container now. So we brought all of our containers up with a Docker up. We can do the same thing and bring everything down with a Docker compose down. So we can do docker-compose down. And that's going to bring down all of our containers. So hopefully you can see how powerful Docker Compose is, because you can spin up your entire environment and bring it all down with just one simple command. So we'll do down. And you'll see that it stops the container, deletes it, and then it removes that the network that it created for us. Also, keep in mind, when it builds the image, it actually builds a brand new image. So if you do a docker image ls, you can see it created an image for us. So it did a React Docker-YT_React App. So it names the image in that same exact format. So this is the one it created. We've now killed our container. If we do a docker ps, it's no longer there. Now, a couple things to note. If you remember our docker run command, where is it? So our docker run command, for some people, you may actually run into some issues if you don't pass in the -it flag for React. So this was kind of broken for a certain amount of time. It looks like we don't need it anymore. But if you do need it, you'll have to pass in the -it flag. So if you ran into any issues with this video and you weren't able to actually get Docker working and React working in a Docker container, you may need to pass in the -it flag. And I did, and the reason I'm bringing that up now, I probably should have done it before, but I had forgotten. But when it comes to our Docker Compose file, the -it flags can also be passed into here as well. So for the I flag, you can do std in underscore open, set to true. And also, I think there's another one for the T. And so for the T flag, we can do dty colon true. So that's going to be the equivalent of passing in the -it flag. But it looks like we don't need it anymore, or I don't in my case. But things may be different depending on which version of React you're using. So keep that in mind. I'm going to just comment that out for now. Now, there's one thing I want to point out with Docker Compose. If you run an up, I want you to notice what happens. Actually, before we do that, let's say we make a change to our Dockerfile, right? Let's say we add a new environment variable. We'll say env, we'll call this Chinese underscore food equals good. Right? So we've made a change to our Dockerfile. And when we do a Docker Compose up, you're naturally going to assume that it's going to rebuild the image. But if we actually do a Docker Compose up, let's actually see what happens. You can see that it created the network, and then it just started a container, right? So it did not rebuild the image. And the reason for that ultimately, and the reason you're seeing all this output is I didn't run the -d flag. But the reason why it doesn't actually rebuild the image is because Docker Compose is very dumb. And Docker Compose just does one simple check. We do a Docker image ls. All it does is it looks for a Docker image with the specific name based off your project directory and the service name. It has no idea if this is the latest image, if this is a stale image. It just looks for an image with that name. And if it sees it, it's not going to rebuild it. So you have to tell Docker Compose when you want to rebuild the image. Because Docker Compose can't figure this out. So we know we put in a new environment variable. And so we have to do a Docker Compose up. And then let's remember the -d flag because I hate reconnecting it. And then just do a -- build. So a build is going to trigger a build again. So you can see it's running through all of the build steps. It's creating a brand new image with that environment variable, and then it brings up a container. Right? And so that's all I wanted to show you when it comes to the Docker up, because a lot of times people forget that, anytime you make changes to your Dockerfile and your image, you have to tell it to rebuild by passing in the -build flag, because Docker Compose isn't intelligent enough to figure that out on its own. But let's go ahead and tear everything down by doing a Docker Compose down. All right, so we've got a solid workflow now where we've kind of automated all of the configs that we need for bringing up our container. However, this will only work for our development environment. Our production environment is ultimately going to be a little bit different. Actually, it's going to be significantly different because right now we're running React in development mode, and it's not actually ready for production. So in the next section, we're going to see how we can set up essentially two different workflows, one for your development environment and one for your production environment. All right, guys, so I set up a few slides to kind of explain the difference between running React in development mode versus running React in production mode. And so right now, we've been running in development mode till now. So anytime you do npm start, that automatically implies that you're running in development mode. But when you're running in development mode, what happens is that React actually spins up your own custom dev server, a little web server that'll serve your React application. And when I mean your React application, all your source code. So you got the index.html file, you got all your CSS, all your JavaScript. And so when your web browser sends a request on port 3000, the web server is going to then send back the index.html back to your web server. And so all of this is running in a Docker container. However, this is just how it works in development mode. In production, it's a little bit different because, first of all, the dev server that comes with React is not production grade, obviously. It's only meant for development purposes. If you sent a couple thousand connections, it would probably destroy it. So when you want to move into production mode, what happens is instead of running an npm start, you run an npm build. And what that does is it creates a directory in your project folder called build. And then within the build, you'll have the final HTML file, your final CSS, I forgot an S there, and then your final JavaScript file. So it's just going to return 3 static files that have all your code baked into it. And that's it. So how exactly do we work with these files in production, right? Because they're just 3 files. And we no longer have a development server when we do an npm run build. We just have those 3 files. So what exactly do we do then? Well, when we go into production mode, we have to set up something pretty similar to what we had with our development server. The only difference is that we put in our own production grade web server. And so we swap out the React dev server with something like NGINX. And it doesn't have to be NGINX. You can use Apache. You can use any other web service or web server that you know of, but you just need something that's able to serve those static files. And so now our web browser can send traffic or send a request to our Docker container on whatever specific port it's been configured to listen on. In this example, I just chose port 3000 again, but you can pick any port. If you wanted to do the default port 80, you can do that. If you, for some reason, you needed to use a non-default port, you can specify any port that you want. That request is going to go to the NGINX server. The NGINX server is going to return those 3 files that it got from when you ran npm run build. And so that's ultimately how our production server is going to work. So now we have to kind of understand how exactly are we going to accomplish that, because we've set up a Dockerfile that creates our own custom Docker image and then does an npm start to start our development server. But this is a little bit trickier because when we do npm run build, it's just going to return a couple of files. So how do we then create an NGINX server and then have those files in that NGINX server serve that in a Docker container? Well, the way we can do that is with multi-stage builds. So till now, we've just been using single-stage builds, but we can create a multi-stage build, which means that you can basically run the from command multiple times, right? The from command determines what base image we're going to use. And so this diagram is going to explain ultimately how we're going to do that. So we're going to break it down into 2 different stages. So the first stage is basically what we had before. So we do the from node, and then a specific version if you're interested in that. We copy the package.json. We install the dependencies. We copy the rest of our source code. And then we run an npm run build instead of an npm start. And that's going to return all of those static files in a build folder. Then we're going to start stage 2, where we do it from NGINX. So we're going to take the public NGINX, the official NGINX image from Docker Hub. We're going to take that, and then we're going to copy the result of this build folder, or the result from stage 1, into the folder inside our NGINX container. And then we're going to start NGINX, and NGINX will then serve those files. So it's actually pretty simple. When you think about it, we just have to break it out into 2 different steps. So let's take a look and see how we can actually accomplish that. All right, so what we're going to do is we're going to have 2 different Docker files. Right now, we just have one. We're going to have one for development and one for production. So what I'm going to do is I'm going to rename this guy. I'm going to name him Dockerfile.dev. So this is the steps that we're going to use for development. There's nothing that changes for development. We're really just focused on what are the different steps we need for production. However, changing this file name does create a few issues. So by default, Docker will only look for a file called Dockerfile. It will not automatically know to pull something called Dockerfile.dev. So moving forward, anytime you do like a Docker build, and then you do the context, we actually have to pass in one more flag. We have to pass in the -f flag for file name, I think. And so now you have to pass in the full path to your Docker file and the name of the Docker file. So it's in the current directory, and then we call it Dockerfile.dev. And since it's in the current directory, we don't actually need the /. And so now if we run that, it's going to create an image. So I just wanted to highlight the difference now that we changed that name. And also in Docker Compose, we're going to have to change this as well, because right now it just says build dot, which is going to look for a file called Dockerfile, which no longer exists. And so we actually have to split out the build stage into a few more configuration options. So now we have to pass in the context, which is just going to be the dot, which is the current directory. And then we also have to pass in the name of the Docker file, which is going to be Dockerfile.dev. And so that's really the only change that you have to make when you change your file name to be .dev and .prod. But now let's go and create our Dockerfile .prod. And let's create that multi-stage build. And so just like previously, actually, I'm going to actually just copy a lot of this. And then we're just going to tweak it. So once again, we're going to copy the node image, set the working directory, copy the package.json, do an npm install, copy all of our source code, We may have some environment variables. Don't worry about those. Actually, we don't need that anymore. And actually, let's remove that from here as well. Same thing, expose 3000. We don't actually need the expose 3000 because remember, we're not actually going to do anything with this node app right here. It's just going to spin up that container and then run all these commands. But instead of doing an npm start, we're going to do an npm run build. And instead of CMD, this is actually going to be a run. So this is going to run at build time. And actually, I could just change this to be npm run build. And so that's the end of the first stage. And that's all we need. We just need to build those files. And then we'll move on to stage 2. So we'll do from. And then from here, let's go to Docker Hub. And I want to search for NGINX. Let's find the official NGINX image. First result's going to be the one that you want. And so this has got some instructions about, how this image is supposed to work. And so let's go back to our source code. We'll do from NGINX. And we'll say copy -- from equals React. Actually, I haven't explained that yet. So let's just copy. Whoops. So what exactly do we need to copy, right? We need to copy the output of this command. So what we can do is we can actually name each stage. So I'm going to name this as, and we can call this, React-build or something. And so then I can say copy -- from, and then we just specify the name. So React-build. Actually, I'm just going to name this build instead. Don't need the React. All right. And from there, we want to copy whatever's in the /app/build directory. Because when we do an npm run build, it's going to create a folder called build in here. So I'm going to just show you that real quick on our local machine, not in our container. And you'll see that it's going to create those files for you in a couple seconds. Just pay attention right up here. You'll see a build folder pop up. Yep, there you go. So we've got the build folder. And it hasn't finished yet. So it's just created a couple of the files. But you'll see eventually an HTML file and a JavaScript file and a CSS file probably. All right, so now you can see we've got under static, CSS, JavaScript, and media. So we're going to copy everything in the /app/build folder. And what are we going to copy it to? Well, we got to figure out what directory we need to paste it in our NGINX container so we know that NGINX will automatically serve those files. If you take a look at the documentation, we want to send it to /user/share/nginx/html. So you put it into that directory and NGINX will automatically serve it for you. You won't need to configure anything else. So let's do /user/share/nginx. Whoops, nginx/html. All right, so hopefully that makes sense. We're just saying from the previous stage called build, I want to copy whatever's in the build directory, which is those static assets, and then paste it into this folder inside the NGINX container. And then lastly, we have to figure out, I think that's about it. So let's save this. And let's try building this image by itself. So we'll do docker build. Now we have to do -f. So we want dockerfile.prod. And then let's give it a name. So I'm going to do -t. We'll call this docker image-prod. And then the build context is the current directory. So let's try that out. And so if we do a docker image ls, we've got our docker image prod. Let's try deploying a container. So I'm going to hit up until we get to that long command that we were used to be running with the docker run. And so a couple of things need to be changed. So this is production. So we definitely don't need the bind mount because we don't want our code to be syncing there. It's production. Then what ports do we want to map? So NGINX by default is configured to listen on port 80. So we got to change that to port 80. And then what port we want to open up on our local machine, it can be any port. It doesn't really matter. I'm just going to do port 8080. But if you wanted to do just port 80, that's fine. Then we have to specify the image. So it's react-image-prod. And then we can call the container React app prod. And then everything else should be the same. So let's try running that. I couldn't find that image. What did I go? Oh, I called it Docker image prod. Okay, that was a bad name. But we can change that. It looks like port 8080 is already taken. Let me check that. Docker PS. Oh, that's my other container I was running earlier today. So I'm going to stop that. And then let's run that command again. Yep. So we're getting this error just because previously it created the container. It just didn't start it because port 8080 was taken. So let me just delete that and then we can just start it from scratch. So docker ps-a, we're going to just do a docker rm react-app-prod. Okay. So now if we run this command, it should start it. There we go. And now if we go back up to here, remember we're not listening on port 3000, we're listening on port 8080. Let's check it out. And look at that, it works. Our application works. If we change our code, it shouldn't change anything because remember, this is our production server. So I'm going to delete the ASDF. I don't need that anymore. Hit refresh. Nothing changes. It should still be there. Perfect. All right, guys. So let's quickly delete this container that I just created for production because we won't need that anymore. So I'm going to do docker rm react-app-prod-f. And now what I want to do is we have a Docker Compose, but right now it's just setting up the instructions for our development environment. We also need to set up the instructions for our production environment. And I'm trying to think of the best way to do this. And I think the easiest solution is to have a separate Docker Compose file for your development environment and a separate Docker file for your production environment. So I'm going to create another file. In fact, I'm actually going to create two more files and I'll explain why. So first of all, I'm going to rename this. I'm just going to call this dash backup. This is just so that you guys can take a look at the configs for when we had the original configuration. But let's create three new files. So I'm going to create a new one. I'm going to call this docker-compose-dev.yaml. Then I'm going to create a new one called docker-compose-prod.yaml. All right, so obviously the -dev is going to have all of the instructions for our development environment. The prod is going to have all the instructions for our production environment. And then finally, I'm going to create another one called docker-compose.yaml. So you might be wondering, well, why did I create another just docker-compose.yaml? We've already got one for dev and one for prod. Well, here's the thing, right? We're only working with one container, so splitting it up between dev and prod is not a big deal. But if you've got 10, 12 different containers, all with a lot of configs, you'll see that most of these containers, the configs for development and production are going to be roughly the same. There may be like one or two changes for each container. And so what I want to do is the docker-compose.yaml is going to have the configurations of containers that will be the same regardless of development or production environment. And then the dev file is going to have only the config differences that are applicable to development, and the production one's going to only have the configs that are relevant to prod. And you'll see that the dev and the prod file, they can actually overwrite configs on the Docker Compose. So you can set up a Docker Compose that has some basic configurations and then override them for each specific environment. And so what I'm going to do is I'm going to go to this docker-compose-backup. I'm just going to copy this whole thing for now. I'm going to put that into my Docker Compose-YAML. So the first three lines are going to be the same because we want to define our service. However, our build, actually, we'll leave the build here for now. Let's take a look at the configs that are going to be the same. So what configs do you think will be the same? Well, the environment variables are going to be different probably. And we know this is only going to be applicable for development environments. So let's remove this because we can just apply the environment variable specific configs inside the prod and the dev YAML files. This one, the volumes are not going to be the same. for prod and dev. You'll see dev just, the dev will have the bind mounts, the prod will not. The ports, so if both, you can configure your NGINX to listen on port 3000 as well. Then you can have a shared ports config, but for us, they're going to be different. So I'm going to delete it from the shared config. And then the build is also going to be different because you'll see one's going to point to dockerfile.dev and then one's going to point to dockerfile.prod. So we can delete that or comment it out. And you'll see that we're ultimately left with nothing. So like I said, we don't technically need this Docker compose YAML file, but in real practical applications, you're going to have more than one container, more than one container, more than one services. And you'll see that there will be a lot of configs that'll be roughly the same across all of them. So there's definitely a benefit to having this shared config file. So I'm going to leave that here. And actually what I'm going to show you is I'm going to uncomment this. And I'm going to show you how we can overwrite whatever values are stored here. So in the prod, we can go under build and just specify a different file and it'll overwrite this. So I just want to showcase that functionality. All right, and then now I'm going to take the backup YAML. Going to copy this and post it into the dev. So this is already the exact configs that we need for our development environment because this is what we were using when we were developing our app. And so you can see we're specifying the dockerfile.dev, opening port 3000, we got our bind mounts, and we got our environment variables. And so now let's go to prod and let's set that up. So things are going to be a little bit different. So first of all, our build is going to be dockerfile.prod. Our ports, remember we changed our ports to be 8080. It's going to map to port 80. We're not going to have a bind mount. And for our environment variables, let's just change this to Sanjeev-prod so we know that it's working. And for dev, we're going to change this to -dev. And I think that should be everything that we need. Let me just double check. All right, so it looks like everything's good to go. So let's test this out. And so what I'm going to do is I'm going to do a docker-compose. So now we have to pass in two different files. So we pass in the -f flag for a file name. And so the first one's going to be the docker-compose.yaml, which is the shared configuration. And the order does matter, by the way. So always start with the shared config file. And let me just make sure I do a save all. And then we pass in the second file, which is going to be the docker-compose-dev.yaml. And then we're going to do up, and then we're going to pass in the -d flag and then the -build just to make sure it builds the images. Although the first time you run it, it's always going to build the image, so you didn't technically need that. So it's created our application, or our container. Let's do a docker ps. And we got our one container running. And so this is our development environment. So we want to go to port 3000. And you can see that it's working, right? We got port 3000. And look, it says Sanjeev-dev. So the environment variable worked. The last thing that I want to test for our development environment is let's go to our source code and let's change a few things. So let's just add some gibberish. Let's hit save. And you can see the gibberish showed up. So our changes are getting synced and React is automatically reloading. So let's tear that down now. So we're going to do a docker compose down, and you're going to have to do the -f flags as well. We'll do down. It's going to tear everything down, and let's try production now. And so it's very easy, same exact command, except instead of -dev, I'm going to do -prod. All right, and now let's test this out. It's going to be port 8080. Okay, and so it looks like it's working. However, there's one issue. Look at the my name, right? It looks like our environment variable, which we passed into our docker compose-prod, did not take effect. In fact, it's actually taking the default one from our Dockerfile, which let's go to our prod. And so we set that here. So what exactly is happening? Well, this actually took me a little while to figure out. But what happens is that all the values of the environment variables, when you're in production mode, get set here. Because once we run npm run build, all of our source code is set. So those environment variables get populated into your code. And then when we do docker compose-prod and we pass the environment variables here, this is passing it into our NGINX container. which is not very helpful for us, right? Which is not very helpful for us because it's not in the source code. And so even though it's running on this server, remember our application is actually running on the web browser. So we actually need to find a way so that we can pass it into the build when it's doing an npm run build. And the only way I could figure out how to get this to work was by doing this. We actually have to pass in arguments. And so arguments allow us to pass data from a Docker compose file into a Docker build file. So let's see how we can do that. Here under the build section, we can pass in args. So we can pass the list of args. I'm going to pass in one called React_app_name. And that equals Sanjeev-prod. We don't even need this line anymore. We don't need either of these lines anymore. So both of those can go. All right, so this argument that we're passing right here will be passed into our Dockerfile. So it's going to get passed into this section right here. And to accept the argument, we have to pass in arg and then React_app name. So this argument is going to be whatever value we set in our Docker compose right here. All right, and then now one last thing that we have to do is we just say React_app-name equals, and then we have to pass in this value. So to use that as a variable, we just do $, and then React_app name. So it's going to take that argument and it's going to pass it into this environment variable. So it gets set when we're actually building the files. So it's a little inconvenient. I actually don't like having to do that, but I couldn't find any other alternatives. So for every environment variable, you're going to have to paste all of those in. It's a little time consuming. That's why I kind of just don't recommend doing React within Docker. I just don't see the true benefit of it, but I just wanted to make sure you guys understood how to do it and why you needed to do it. So let's test this out now. Let's save everything. And I'm going to tear everything down first. All right, and then now let's do an up again. And remember, we want to rebuild this. Actually, let's put that space back in there. We want to, let me save that. We want to rebuild it, so make sure you pass in the -- build flag. So anytime you change anything with the Docker files of any of your services within your Docker compose, you want to make sure you do pass in the -- build, because Docker compose isn't smart enough to figure that out on its own. It's going to rebuild your image. All right, and so now that it's running, let's hit refresh and let's hope that the environment variable got set. And look, it's finally been set correctly to Sanjeev-prod. So that's how you can pass in environment variables when you're working with React in a production environment. All right, so that's pretty much everything I wanted to show you. There's one last thing I wanted to show you when it comes to a multi-stage build, and then we can kind of wrap up this video. So if we actually go back down here, and I'm going to tear everything down. Here we go, down. I want to show you what we can do when it comes to multi-stage builds. So we've got our prod file, and we've got the two different stages. Let's say you wanted to build an image, but you only wanted to run some of the stages. Well, you can do that. So when you do a Docker build, and then the context, and then let's just give it a quick tag of multi-stage example. What we can do is we can pass in the, well, first of all, we also have to pass in the -f for the Dockerfile name. So we'll do Dockerfile .prod. And then we can pass in the -- target flag. So this target flag is ultimately going to tell Docker what is the final stage that you want to run. So in this case, we only have two different stages. But let's say we added a couple more, right? Let's say we go to the top and we just added, from, let's say, I don't know, is there a Postgres? There's probably a Postgres. And then we do some steps, whatever steps that we wanted to. What we can do is, if we say -- target equals build, sorry, and there's no equal sign. So if we just do -- target build, it's going to run stage 1 and then stage 2. So by specifying the name of the specific stage, that's going to be the final stage that runs. So anything after it will not run. So if we remove this, In this case, we just have 2 stages. So if I just say --target build, it's only going to run this stage because it's the final stage. And since it's also the first stage, we're only going to have 1 stage that runs. So if we run that, you're going to see it builds the image. But you'll see that it will not do the NGINX image. And so you see it just stops right there. So there's no NGINX involved. So if you've got like really complex Docker files with like, multiple stages, you may not always want to run all those stages. You may only want to run a couple of the stages. And so this is how you do that by passing in the --target flag.